go into the detail of the drawbacks and the advantage of linked list. Let us see first what is linked list and how it is represented and what is there in that. Okay, so if you see the definition of the linked list, you will see here that a linked list is a sequence of data structures which are connected together via link. They are connected together link, that's why they are called as linked list. So for example, if this is one item data, then this is another data. So this data is connected to this data via this link. So this is the link, and the information of this link will be available here itself in this data. So this linked list will contain data items. Now for example, here throughout our example we will consider only one data item, right? We will consider only one data item, but it is not necessary that you should have only one data item. You can have multiple data items, but along with the data items, you will have the link which is pointing to another data item, right? Which is pointing to another data item, and again here you will find the link which is pointing to another data item. So from one data item you can move to another, from another you can move to third, and so on and so forth, right? So that's why it is called as linked list, a list of items connected by links. Okay. So it is the most used data structure whenever you want to work with memory, right? Whenever you want to work with memory, then in that case we use linked list instead of array, because array is having a continuous memory, right? Array is having continuous memory. Okay, but linked list is not having continuous memory, and it can be worked with limited memory also. So we will see one by one what is there in the linked list. So the first thing is that each link each link of linked list can store a data element called an element. So this is the suppose list. So here we are storing data, right? Data element. Then it is also having a next field which is pointing to another list which is again containing a data and again containing the field, right? So in this way you will have multiple data items along with next field in each list, right? And the one which is the last will contain null, right? So if the next field contains null, it means it is the last. Now, from where you will start, definitely you will require a starting point. So there will be a starting point which will point to the first item in the linked list. So that is this linked list. A linked list contains the connection link to the first link called the first. You can call it as a first also, you can call it as a start also, you can call it as a head also. It depends on you which nomenclature you want to follow, right? So three things are to be kept in mind. One, a data is there, another, a next field is there, and the start of the linked list is necessary, because from there you will able to see the list, because you need only one address from where it is starting, right? Suppose this is the start address is 1,000, so you will go to 1,000. From 1,000 you will be getting data, and also you will get say 1,050. So 1,050 is the address of next data. So here you will get data, again here you will get say 2,000. So again at 2,000 you will be getting another data item, and here the address may be 3,050. So you will go to 3,050 likewise, and at the end you will be able to see here null. So if you reach null, it means this was the last element of the linked list. So three things you have to keep in mind, that data element, a next field, and the starting, right, from where the linked list starts. That is more important. Okay, so this is how you can say that this is the linked list. Here I am using word head. You can use word start also. It depends on you. So it is pointing to a node, right, which contains data, which contains next element. So the address of next element. So from this you will go to the next node, and likewise you will go on traversing, right, and at the end you will find that it contains null, right. So once it contains null, the list is end. Okay. So always you have to keep in mind that to start from where to start, you should have the starting address of the linked list. That's all. Once you get the starting address, you can go through the entire list. Now from this figure, what drawback you can find out? Can anyone tell me? Seeing this situation, what you can tell on this figure? Just when I'm telling you that if you want to traverse the list, if you want to go through the list, you should require the start, or you should require the head from where the list starts.
Sir, we cannot go to the previous list.
Yeah, we cannot go to the previous. Once we cross this node, if we are at this node, we can't go to the previous node, right? And one more thing, that we can't go directly to any intermediate node. We have to go to the starting node first, and then we have to go through each and every node in the list. Even if you want to access only one element, right? Suppose there are 50 nodes, right, in the list. These are the 50 nodes, right? And you want to access 27th node, for example. So you have to go through 26 nodes, and then you will reach to 27 node, and then you may not access further nodes. But definitely, if you want to access 27 node, you have to traverse to 26 nodes, right? So that we can draw conclusion from here. So these are the drawbacks of the linked list, right? What are the drawbacks? That we can't go to the previous element, and we can't go directly to the required element. Okay. So it is just like in your old days, you were having cassettes, audio cassettes, right? Have you seen that? Anyone? Audio cassettes were there, which contains say 10 songs. So if you want to listen third song, you have to start with first only. There you are having fast forward buttons were there, right? But today in CD, you can select any song, right? So here the retrieval was sequential. You can say, what is the retrieval mechanism? Sequential. And here in CD, the retrieval is random access, right? Just a minute. मैडम लेक्चर में हूँ. हेलो हेलो. हाँ ठीक है, लेक्चर के बाद कॉल कर रहा हूँ. हाँ ओके. So in CD, if you are having any information or files, you can have random access. Random access means if there are 3 songs in that, you can play any song, whatever you like, right? So that is called as random access. But in audio cassettes, the songs are to be listened in a sequential manner only, right? Definitely you are having option of fast forward or forward button. So similarly, you can compare array and linked list, right? You can compare array and linked list. So array, you can say it is analogous to CDs, and linked list, you can say it is analogous to audio cassette, right? Fine. So because in array you can access any element. For example, you are having array of A of 10. So directly you can access A of 5. You can access A of 4. Any element you can access directly. You don't have to go through A0, A1, A2, A3 like that. Why? Can anyone tell me why it is so? Why we are able to access any element in array?
Also because of the base address.
No, base address is given here also, na? In linked list also you are having starting address, right?
Also it is continuous in nature. So for
Yeah,
example,
because the data is stored in a continuous fashion, it is possible to calculate the address of that number which you want to retrieve, right? That's why the random access is possible in array. But In linked list, you are having only one address. You don't know where the other nodes are there in the memory. So for that purpose, you have to visit each and every node, right? And from that node, you will come to know the information of next node, and so on and so forth. You can go, right? So that's why we say that the access to the linked list is sequential, whereas access to the array is random. Okay, so that thing you have to keep in mind. Now next is what kind of operations we can perform. So definitely whatever operations we can perform on stack and queue, the same kind of operations we can perform on linked list also, with some variations are there, right? So you can insert the element, you can delete the element, you can display the element, you can search the element. Now insertion may be of different type that we can see. Deletion may be of different type that we will see, right? So all the operations which we have seen in our previous data structures, the same kind of operations we can perform on linked list also. You will see one by one. Insertion means what? What specifically you can say? You can say I want to insert at the beginning, right? At the beginning, or you can say I want to insert at the last, or you can say I want to insert at the middle, means anywhere in between. So there are three types of insert operations. You can insert at the beginning, you can insert at the end, or you can insert in between. Similarly, you can say about deletion also. You can delete the element which is at the beginning, or we can use delete the element which is at the last, or you can delete the element in between, whatever the elements are there in between begin and last, that you can delete. Okay, so you can further explore insertion for three operations, deletion for three operations. Then you can display the list, or you can search the list also. You can perform the search operation also. Now how the search will be there? The search will be always sequential, right? There will be a linear searching, you can say. Okay, I think you might have heard the word binary search. Have anyone heard this word binary search? किसी ने सुना है ये नाम?
Yes, sir.
Yes, sir.
Yes. So binary search is not applicable on linked list, right? I will tell you the difference. Reason? Can anyone tell me? कोई बोल सकता है कि
So
बाइनरी
because
सर्च?
it access a specific element,
Yeah,
while sir, because it access a specific element while searching, and linked list we have to transverse through the list.
yeah. Binary search requires sorted order, right? Binary search requires sorted order. Okay, and if it is sorted order, then suppose the elements are 2, 3, 5, 6, and so on so forth. So if this is the middle element, from this middle element you can go in forward direction only, because we are having the address of next, but we can't move to the previous. And that's why this linked list is not suitable as far as singly linked list is concerned, because we are talking about the linked list, and by default when I am not saying anything about this, it is a singly linked list because it contains a single pointer which is pointing to next element, not to previous element. It is always pointing to next element, not to previous element. So there is a single pointer in this linked list. So when I say linked list, it by default it means singly linked list. Okay, so we cannot move further, right? Backward direction, and that's why the linked list are used for sequential search only or linear search only. Okay, so now what we have seen so far, that in linked list you have to keep three things in mind. One is data, other is next pointer, and the third one is starting address of the start first element. These three things you require to work on the linked list. Okay, and the operations which we can perform are the same operations as we have seen in our previous data structures. Those are insert, delete, display, and search. Insertion can be of three types: insert at the beginning, insert at the last, or insert in between. Same is the case for deletion. Delete at the beginning, delete at the last, and delete in between, right? And searching is sequential search. Okay, fine. Now come to the point where we need to differentiate between array and linked list, right? So why, first we will see why linked list. Because array is used to store linear data of similar types, no doubt. Linked list can store multiple type of data. You can store int, you can store, because it is a structure, right? It is called as structure. Linked list is implemented using structure in C or C++. In C++ we are using class, in C we are using structure, and in Python again we are using class, right? Because C++ and Python are object oriented, right? So the structure and class can store multiple elements of different data types, right? Multiple elements of different data types. You can store int also, you can store char also, right? You can store char also, and likewise you can store float, whatever data types are available that you can use. But as far as array is concerned, if you are saying int a of 10, so you can store all the elements of type int only. And that's why it is written that array can be used to store linear data of similar types, all similar types, right, in array. But what are the limitations of array? The size of the array is fixed. When I say a of 10, that means you can add only 10 elements, that's all, not more than that. Okay, so that's why we should know the upper limit. That upper limit is 0 through 9 in case of 10 in advance, because you cannot store more than that. The suffix value, this value should not be greater than 9. That you should know in advance, right? Whatever may be the value, it may be 9,000, it may be 1,000 or 1 lakh, whatever it may be, right? So the main drawback is the array size is fixed. For example, if you think that you are having say now suppose 63 students are there in A and B division, so I declare array of 63, that I want to store the information for 63 students. But as you see, uh, in none of the lecture the 63 students have come here, right? The maximum was 40 students, so always the 23 elements were vacant always. But since the size of the class is 63, I have to allocate memory for all 63 students, right? Irrespective of the attendance. So because of this, the wastage of memory is there, no doubt. There is a wastage of memory. And one more drawback is that if you want to insert a new element in an array, it is very expensive. For example, if you are having array containing these numbers 5, 6, 7, 8, 9, 10. Now you forget to insert, say, 4, right? After 0, 1, 2, 3, you forget to insert here 4. So if you want to insert here, what we would like to do, we have to shift this 10 to the next location, 9 to this next location, 8 to this location, 7 to this location, 6 to this location, 5 to this location, and then we will insert 4 here, right? So that's why it is expensive. That for one insert you may have to perform several moves. Similarly, it is the case for delete also. If you want to delete any atom in between, suppose if you want to delete 6, then 7 has to move here, 8 has to move here, 9 has to move here, 10 has to move here, right? Then only we can say that the delete is performed. So insertion and deletion is very expensive in case of array, right? That's why whenever you come across a situation that you have to perform continuously insertion and deletion, then you should not prefer array, right? But if you want to access randomly any element, most of the time if you want to access only once the stored, then the next thing is simply to access. Say for example, if I have uploaded my song on YouTube, I will upload only once, and what will happen after that? Only it will be used for downloading, right? So uploading is done only once, but downloading is done many times. So what should be my strategy? That for uploading, even if I take 2 minutes more, doesn't matter. But for downloading, the time taken should be less, right? Because it will be downloaded many times. So I should use the suppose I'm encrypting my video, right? I'm encrypting my video because only the authorized person should see that video. So I will encrypt only once, right? Because it will be encrypted once and it will be stored on the server, whereas it will be downloaded many times. So whenever it will be downloaded, it has to be decrypted, right? So encryption is one time and decryption is multiple time. Okay. So what strategy I have to follow? That encryption should be done in such a way that decryption becomes easy. Means if encryption is taking more time, doesn't matter because it will be done only once. But decryption will be performed multiple times. So decryption time should be less as compared to encryption time. So this is the situation. This is the application. So see, in the similar sense, whenever you will come across the problems where you want to store the element only once, but you want to retrieve the elements multiple times. So for retrieval, the timing should be fast. So array is the most suitable data structure for retrieval of elements. But if you want to continuously change the information of the elements, then you may require to insert the elements, you may require to delete the elements. So in such cases, array is not suitable. So depending on the situation, we have to select whether we should go for array or we should go for linked list. Both are having their own significance, right? It is the user who has to select the appropriate data structure, right? So what are the advantages of linked list? The very first advantage is dynamic size. The size is not required to be declared at the start. At the start, you should have only one node, right? And you will have a starting pointer which will point to this first node. That's all. If you want to add only one element, that's all. Okay. But if you want to add another element, again you will allocate memory for another node and you will store the address here in this node and you will go here. So as and when required, you can grow on increasing the size of the linked list, and that's why it is called as dynamic, right? Dynamic means at runtime. Whenever the program is running, at that time you can decide how many elements you require, right? And the other thing which is more important is that ease of insertion and deletion. Suppose this is the linked list, right? From here you are getting the address of this, from here you are getting the address of this, right? If you want to delete this, what you should do? You have to store the address of this node here. So instead of pointing to this, now this should point to this. That's all. Automatically this node will get deleted, right? If the first node is pointing to third instead of pointing to second, if this is the first node, this is the second and third, first is pointing to second, second is pointing to third. Now if I want to delete the node number 2, what I have to do? I have to say that 1 will point to 3. That's all. If I do this, the 2 is automatically removed from the list. Actually it is there in the memory, but now we have lost the address of 2, so we won't be able to refer it no more, right? Okay. So two advantages are there. One is dynamic size and other is ease of insertion and deletion. I have talked about in deletion here. If I want to insert, suppose this 1 is pointing to 2 and 2 is pointing to 3, right? And I want to insert one more element, say this element I want to insert. So what I will do, 1 will point to 5 and 5 will point to 2. That's all. This link I will break and I will say 1 should point to 5 and 5 should point to 2. So this 5 is inserted in between 1 and 2, right? So these operations are very simple as compared to array, and that's why the 2 points are very important as far as linked list is concerned. That is, size is dynamic and the operation for insertion and deletions are easy as compared to array, right? But definitely, since there are advantages, there will be drawbacks also. Now, what are the drawbacks? The first, which we have seen, that random access is not allowed. That means if these are the elements, you cannot directly go to 2, you cannot directly go to 3, or you cannot directly go to 5. You have to start with always 1, because 1 will tell about 5, 5 will tell about 2, 2 will tell about 3, right? And that's why uh, it takes more time to retrieve the number as compared to array. And one more thing, extra space is required, because here along with data, address is also stored. So additional space for storing data is required. Okay, additional space for address is required. And one more advantage is there, which is more technical actually. I will try to explain you, because you are not from computer background. Have you ever heard this word cache memory?
Yes, sir.
Yes.
Okay.
Yes. Can anyone tell me what is this cache memory? कोई बोल सकता
Sir,
है?
it is actually a collection of files that we frequently use. So that is stored in the memory. So for whenever we have to again search that particular file, it will save our time and we get it back
Yeah.
from the cache.
Okay. Good explanation. I will just tell you. Now suppose this is your microprocessor, right? And this is your primary memory, right? I think all of you know about primary memory, because here is the hard disk. From hard disk, the program comes to primary memory, and then microprocessor fetches the data or instruction from this primary memory, right? It can fetch the instruction, it can read the data, and it can write the data in primary memory. And from this memory, the data is again given back to hard disk. Okay. Now what happens? This primary memory, you require, say nowadays you can say that 4 GB or 8 GB or sometimes 16 GB. So this primary memory should be less expensive, right? So that we can purchase it, है ना? कीमत कम होनी चाहिए इसकी, right? Then only we will be purchasing. Now what happens? The CPU speed is more as compared to the reading and writing speed of primary memory. So whenever the MUPI wants to read, the primary memory should write the data. If MUPI wants to read, primary memory will write the data. So because the speed of CPU MUPI is more as compared to primary memory, MUPI has to wait. Microprocessor has to wait till the primary memory writes the data onto the data lines, right? So this waiting period is more. So in order to avoid waiting period, what we do, we purchase another memory which is called as cache memory, whose speed is equal to microprocessor speed. Whose speed is equal to microprocessor, because its speed is more, it is more costly, right? So that's why if you are having 4 GB RAM, you are having 2 MB cache memory or 4 MB cache memory. So your data is coming here first in the cache memory. First time microprocessor has to wait, no doubt. But since the program is written in a continuous way, the block is transferred from the primary memory to the cache memory. And then the microprocessor will fetch without wait, because now the speed of microprocessor and the speed of cache memory is same. So there is no waiting period in between. So that is the advantage of cache memory, right? Now, when I say it is not cache friendly, what does it means? That because if suppose this is my primary memory, you will have one element here, linked list element 1. You may have linked list element 2 here, right? Because it is not continuous in nature. Now, if you want to move this, suppose this is in primary memory, if you want to move this data in cache memory, right? Whether it is in continuous memory, no. So if you want to move here, and the difference between this is 2000, if you want to move LL1 and LL2, you have to move other elements also in between, right? Because it is not continuous in nature, and that's why it is said that it is not cache friendly, right? But if you consider array, then what is about array? Array is having continuous memory. So if you have access to 0 element, then 1 element, 2, 3. So if you will read this, Along with this, you can read all other also in a block in the cache memory, right? So first time the entire array will be read from primary memory to cache memory, and then from cache memory to microprocessor it will be read in no time. And that's why arrays are cache friendly, because they are stored in a continuous locations, whereas linked list is not cache friendly because they are not stored in continuous locations. They are stored at different places. Wherever memory is available, there the data will be stored, right? So considering this, if time is a constraint, right, that you want to retrieve in no time, right, then what will you prefer? अगर मैंने प्रॉब्लम स्टेटमेंट दे दिया आपको और बोला कि नहीं मुझे रिट्रीवल फास्ट चाहिए, दैट इज माय प्राइम रिक्वायरमेंट, मेमोरी चाहे जितनी लगे लगने दो, बट मेरे को रिट्रीवल फास्ट चाहिए, तो आप क्या यूज करोगे?
अरे
एरे यूज करोगे. तो ये कस्टमर की चॉइस रहेगी, राइट? डिपेंडिंग ऑन द प्रॉब्लम स्टेटमेंट यू विल सिलेक्ट अप्रोप्रिएट डेटा, राइट? फिर तब आप मेमोरी का नहीं सोचोगे, बिकॉज अल्टीमेट एम इज व्हाट? कस्टमर सेटिस्फेक्शन. So whatever is problem statement, accordingly you will select the data structure. And for selecting appropriate data structure, you should know pros and cons of each and every data structure. कि हर एक डेटा स्ट्रक्चर का क्या प्लस पॉइंट है और क्या माइनस पॉइंट है, और हमारी सिचुएशन कैसी है. डिपेंडिंग ऑन आवर सिचुएशन वी विल सेलेक्ट आवर डेटा स्ट्रक्चर. सो इसमें हम ये नहीं बोलेंगे यही अच्छा है वो अच्छा है. लिंक लिस्ट इज ऑल्सो गुड इन सर्टन केसेस, array is good in certain cases. Now in which case you are at present, accordingly you will select the data structure. Any doubt so far? किसी को कोई डाउट है?
No,
Yes.
sir.
Okay. So I was talking about linked list, that by default the linked list is called as singly linked list because it contains only one pointer. Say this is the data, and you are having only one pointer which is pointing to next location, right? So that's why it is called as singly linked list, because it consists of only one pointer. Now when I say that it consists of two fields, what I am trying to say you that the one field is for data, but it is not always necessary that you will have only one data field. You can have multiple data fields, but for sake of convenience we are considering only one data field, and that's why it is written here that each node is consist of two fields. Not necessarily always two fields, but minimum two field you can see here. Okay, so the first field will hold the data and the second field will hold the references to the next node. So this starting address must be additional requirement. What the starting address you should have with you. The starting address will point to the first and then it will go on, and the last will contain null. If the next value contains null, that means this is the last node of the linked list, right? So how to declare it in terms of any computer language? So you can have the data type. Now here the data type is linked list. In C we can write struct. In C++ we will write class, or in Python also we will write class only. So this is the name of the node. Normally we give the same name because we try to identify the meaning depending on its content. So this node will contain data and the node will contain the next field which is pointing to the node of same type, right? And that's why it is called as self-referential. We have talked in our prerequisite. I have talked about self-referential. The structure pointing to itself is called as self-referential, right? So if you are trying to implement in C or C++, you should have the clear understanding of pointers. I think I have explained you the pointer, right? What is the advantage of pointer? Can anyone tell me? Advantage of pointer? Okay, I will tell you. Suppose I have declared one variable int a, right? Am I audible? Hello?
Yes, I'm audible.
Yes, sir.
Okay. So I will explain just in 1 minute. I will explain you the concept of pointer. Suppose I am having one variable int a. What happens internally? A symbol table is created, right? When the compiler compiles the program, a symbol table is created. In this symbol table, you may have multiple variables, right? Here also and here also. So somewhere in symbol table, a is stored, and the address of a is stored, say 2000. Now, whenever you say a is equal to 10, what happens? First, the compiler search the symbol table, then it will go through the symbols, then it will come to know, yes, this is a is there, and then it will read address 2000, and then what it will do, it will store the value 2000 to the memory location 2000. So this is called as indirect addressing mode, right? So indirect addressing mode takes more time as compared to direct addressing mode. I think you might have studied addressing mode, right? Now, if I declare one pointer here, star ptr, and if I say that ptr is equal to ampersand a, so what I'm doing now, this is my pointer variable. So, address, what will happen? Instead of ptr, what compiler will do here, it will write 2000 is equal to, in bracket 2000 is equal to 10. When I say a is equal to 10, what it will write? In bracket 2000 is equal to 10, it will write. Okay. So now there is no need to search the variable in the symbol table. Directly address is given here. So 10 will be stored directly to the address 2000. This is the biggest advantage of pointer, that accessing the element is fast with the help of address. So direct addressing mode instead of indirect addressing mode, right? So you should know the concept of this, because with the help of pointers only, because pointer works with address and in dynamic memory allocation you require to store the address. So for storing the address you will require pointer variable, right? And that's why the concept of pointer should be known to you. You can go through the net and you can just write the pointers in C or pointers in C++, and you will have multiple pages on the web, so you can see some basic programs and you can try to run them programs. If any problem is there, you can share that problem with me. Fine. Then what was the drawback of singly linked list? What was the drawback? That we can go in only one direction, right? हम किसमें जा सकते हैं? केवल one direction में जा सकते हैं. Because suppose if I visited this node and I move further, can I go back to the previous node? No, because I don't have any address of previous node here. So you can traverse the linked list in only one direction. So that is the drawback of singly linked list. Any doubts so far? So if I want to move in either direction, either direction, so this is the linked list, the elements are there. From here I should go to this, from here I should go to this, and from second I should come back to 2, from third I should come back to, so this is 1, 2 and 3, right? From 1 I should go to 2, from 2 I should be able to come back to 1, or I should be able to go to 3. From 3, now if this is the last node, so I should be able to come back to 2. So if this is your requirement, that you should be able to traverse in either direction, right? So instead of singly linked list, you will be having a doubly linked list, right? So can anyone tell me what will be the contents of this doubly linked list? Instead of one address field, you will have two address fields. One which is pointing to the next and the one which is pointing to previous, right? Along with data, right? Along with data, you will have two more fields. In singly linked list, you are having only one address field, but in doubly linked list, you will have two address fields. One will point to the previous node, other will point to the next node. So here, one drawback we can solve, that it was only one way in singly linked list, but in doubly linked list, it is two way. You can go anywhere in between. आप 5 से 4 पे पीछे भी आ सकते हैं, आगे भी जा सकते हैं. सिंगली लिंक लिस्ट में केवल आप आगे जा सकते थे, right? That is the only difference between the doubly and singly linked list. That traversal is possible in both directions. Traversal means visiting the node is possible in both direction, whereas in singly linked list the traversal is possible only one direction. It was unidirectional. Doubly linked list is bidirectional. You can move either in this way, or you can move in this way, because it has two address fields. This is the previous address, this is the next address. Previous address, next address. From this previous address you will go to, if this is the first node, you will go to the start, and from next address field you will go to the next. So likewise, instead of one address field you will have two address field. So otherwise all the type of operations are same. So what are the advantages of DLL, doubly linked list or singly linked list? That we can go in both direction, and we will see this in detail. The delete operation in DLL is more efficient if a pointer to be node to be deleted is given. अगर दिया है तो efficient होता है. ये हम example के through देखेंगे. In next lecture we will see all the examples, and we can quickly insert a new node before a given node. So these are minor advantages actually, but the biggest advantage is the first one, right? These are the implementation point of view advantages. These advantages are from implementation point of view. Okay, so from implementation point of view, you can say that the operations are more efficient as compared to singly linked list, right? So that is the advantage. The disadvantage is what? That always it will require an extra space for an previous pointer, right? Because one more pointer is added, so you will require extra space. That's all. Okay, all operations are required an extra pointer, so that is the only drawback, that you will require an extra space for storing the address of the previous, right? So these are the operations which we can perform in different ways, that how you can add the node. These are all type of variations are given here. So in implementation part we will see all these variations, that how to insert a node at the start of DLL, or after a node, or at the end of DLL, or before a given node. Because suppose these are the nodes, right? These are the nodes and you want to insert here, so you can insert after this or before this. So there is a difference between inserting after and before. So how to do that? How to insert before the last node? How to insert before the first node? All these operations we are going to see in Python, right? I will explain the code of Python, that how these operations are being performed either in doubly linked list or in singly linked list. That we will see. Okay. So any doubt? If anyone is having any doubt, please feel free to ask. Yes. Anything is to be asked by the students? As of now, no doubts. But now please go on reading the things, so that if any doubt comes, you should be able to ask me the doubts, because exam is there now. On 21st of August, we are having exam. I will take attendance. I will just say today's date is 11/8.
11.
A division. I will just now A number, roll number A division, roll number 1, 2, 3, 5, 6, 8, 9, 11, 12, 13, 15, 16, 18, 19, 24, 25, 28, 30, 32, 33,
And sir,
uh, 40, 43.
Yes,
Now
sir.
B division.
40.
Yeah. Who is Amay Parab?
Yes, sir.
What is your roll number? Why you have not joined with the roll number? What is your roll number? Which division?
Sir, 23.
Which division?